Okay, AP Chemistry students, welcome. In this video, we're going to look at how to determine the empirical formula of a compound given or using the law of definite proportions. So here's a pretty common question that you could come across. A compound consists of 48.65 grams of carbon, 8.11 grams of hydrogen, and 43.24 grams of oxygen, not nitrogen, it's oxygen. What is the empirical formula? Remember, the empirical formula is the lowest whole number ratio between the different atoms inside of the formula. Well, what is that exactly? First thing you should do when looking at a problem like this is determine what are the atoms that I have in this formula anyways. And as it turns out, the atoms in this formula are carbon, hydrogen, and then of course oxygen. So whatever my formula is, I need to have a carbon, hydrogen, and oxygen. What are their subscripts? I don't know. That's what I have to figure out. And I have to use the numbers up here in order to figure those out. Because remember, these numbers down here are mole amounts. Okay? And we were given the grams. So guess what we're going to have to do to those grams, ladies and gents? Convert them to moles. Alright? And then that is going to be the beginning step into determining what is the empirical formula for this substance here. Okay? Alright, let's start with carbon. This sample has 48.65 grams of carbon. That's what the analyzer told us. How many moles is that? Well, we need to use a conversion factor. Okay. And the conversion factor is what for mole amounts, ladies and gents? When converting grams to moles, we need the molar mass, okay? And so we're going to put the grams on bottom so they can cross-cancel. The molar mass of carbon, if you look at your periodic table, is 12.01 grams to every 1 mole, okay? Before we calculate that, I'm going to set up all the other ones as well. For hydrogen, 8.11 grams in the sample based on what the analyzer told us. And then we have grams to moles. The molar mass of hydrogen is 1.01 grams to every 1 mole. Then for oxygen, inside this sample is 43.24 grams. We take those grams, convert them to moles. Oxygen has a molar mass of 16. Okay. Alright, now let's go through and calculate the molar amounts. Alright, and make sure you're paying attention to your significant figures. We have 48.65 times 1 divided by 12.01. Oops, I typed that in wrong. 48.65 divided by 12.01. That's going to be 4.051 to 4 significant figures moles. Okay. Next one is 8.11. divided by 1.01, we'll need 3 sig figs for this one, 8.03 moles. And then the last one's 43.24 divided by 16.00 to 2 sig figs with 2.703 moles. 4 sig figs, okay? Alrighty, now I know what you're thinking. Take these numbers, put them with the subscripts, and then we have our empirical formula. Well, if you're thinking that, that is not correct, okay? This is not the simplest whole number ratio. Not only are these numbers not whole numbers, they're decimals, but they're also not the simplest ratio. And the ratio is a comparison of all these mole amounts here. Now, in order to get the simplest ratio, we have to find the smallest number of these 3, and then we divide every number by that smallest number. That gives us the most simple ratio. Alright, what is the most simple number here, or the smallest number? Well, it looks like it's 2.703. That is the smallest number out of the 3, so we are going to divide each one of those by that number. 4.051 divided by 2.703 mole. 8.03 divided by 2.703 mole. 2.703 divided by 2.703 mole. This is going to get us our simplest ratio. Alright, let's go ahead and divide it out. Don't forget these moles will cancel here. 4.051 divided by 2.703 comes out to be about 1.5. Now, we want these to be whole numbers, but we can't really round them to a whole number unless it was maybe like 1.9. And I know you're thinking, make this 2, but you can't do that. 1.5 is too far away, so we're going to just have to leave this as a whole number right now, or as a decimal right now, and then get fancy later. Don't worry, it's not bad. Alright, for the second one, 8.03 divided by 2.703. 8.03 divided by 2.703. This is 2.97. 2.97 is close enough to 3 that we can just go ahead and round it to 3. And for this last one, this just divides out to be 1. Okay? These are our simple ratios. They're not our whole number ratios, but we can get them there. We'll start by putting them into the formula. Okay? So we have C 1.5, H 3O 1. Okay? That's the simplest ratio, but it's not the whole number ratio. How do you get this to become a whole number? Specifically this one. Well, we're going to divide by a coefficient, or not divide, we're going to multiply by a coefficient that will turn this into a whole number, okay? In this case, we're going to multiply it by 2, because if you multiply 1.5 times 2, it will become 3, which is a whole number, alright? Not only will we multiply this by 2, but we'll multiply this one and this one by 2 as well. So we have to multiply this whole thing by 2 to get it to a whole number. That is the easiest way to get something to a whole number when it's in halves like this, okay, is to multiply it by 2. So our real empirical formula is C 1.5 times 2 is 3, H 2 times 3 is 6, O 2 times 1 is 3. This is our empirical formula for this problem. Okay, this has to be one of the tougher examples because we were given a decimal here. Let's look at a sample in which case you're given percentages, not the grams. Okay, now remember in the last example when we're figuring out the molecular formula, figure out what are our 3 compounds, or what are our 3 elements, I mean. We have hydrogen, carbon, and oxygen. So we have carbon, hydrogen, and oxygen. We don't know what their coefficients are, but we will figure them out. Or their subscripts, I mean. Now we take these numbers and convert them to moles. There's just one problem. They're all percentages, and we can't convert percentages to moles because there's no conversion factor between those two. In this example here, ladies and gents, it didn't tell us how much it initially put in the analyzer. It didn't say if I put 100 grams of this mystery substance or 10 grams of this carbon and so forth and so on. If it gives you percentages and it doesn't tell you what masses they put in, you can make an assumption. And the assumption that we're going to make is that we put 100 grams initially inside of this analyzer. That's a good thing to do because it makes your life a whole lot easier, because 52.14% of 100 grams is 52.14 grams. 13.13% of 100 grams is 13.13 grams. 34.73% of 100 grams is 34.73 grams. By assuming 100 grams, we are literally taking these percentages and converting them to grams, okay? Alright, now that all of these are grams up here, we can finally convert them to moles and then find the smallest ratio and calculate our empirical formula. Okay? $52.14 grams of carbon, 13.13 grams of hydrogen, and then 34.73 grams of oxygen. Okay, now we're converting these to moles, so guess what you're going to need? The molar mass. Alright, so for carbon, grams on bottom, moles on top, so the grams can cross cancel. 12.01 to every 1 mole. For hydrogen, grams down here, moles up here, 1.01 to every 1 mole. For oxygen, grams down there, moles up there, 16.00 to every 1 mole. Alright, let's figure out how many moles are in each one of those now. 52.14 divided by 12.01, 4.341. 13.13 divided by 1.01, that's going to be 13, I think. Yep, 13.00 to 4 sig figs. And then 34.73 divided by 16, I'll put that in wrong, 34.73 divided by 16. This is going to be 2.171. And these are moles. Okay. The next step, ladies and gents, is to figure out the lowest number ratio. Alright, which means we got to pick the smallest number. In this case, it's 2.171. So we'll divide everything by that. Alright, let's go ahead and calculate that out. 4.341 divided by 2.171. That comes out to 1.99, which is essentially 2. 13.00 divided by 2.171. 5.98, which is essentially 6. It's close enough to round. And this comes out to 1. Alright. Hey, this is really, really nice. All of these came out to be whole numbers, so we don't have to multiply by 2 to get to a coefficient or to get rid of halves. So we will just go ahead and associate each of these with their subscript. That means this formula is C2H6O1, or we just leave the 1 off, we don't have to show it, and then that is the empirical formula for this compound here. Ladies and gents, I know this is a really involved calculation. I highly recommend that you re-watch this video before going into the example problems on the next page in the soft check quiz, okay? If you have any questions, don't hesitate to get a hold of me on the Remind or send an email.